we know 1 over sine t is cosecant t. Yes. But you have to call 1 divided by some function of t, x, t, doesn't matter, is not equal to f inverse of t. Yes? What is the purpose of an inverse function? What does it do? It will undo whatever the function did. Yes? To t or x. So if you plug in sine t, give me a value for t between 0 and 2. What is it, Peter?
5 over 6.
Pi over 6. If t is pi over 6, do we know what sine pi over 6 is? What is it? Is it 1/2 or is it square root of 3 divided by 2? This modeling can't get square root of 3 divided by 2 for 30 degrees. Is that correct? No. Cosine of pi over 6 is square root of 3 divided by 2. Now, pick up your calculator and do 1 over 1 divided by sine 2, which is simply cosecant t. What should you get? That's easy. 1 divided by 1 over 2. Take up your calculator. Find sine inverse of pi over 6. Clearly, cosecant pi over 6, which is 1 over sine pi over 6, is not equal to sine inverse of pi over 6. If you say that they are equal to, you're making that mistake. Good. So an inverse function is not the same as the reciprocal of a function. That's it. What does an inverse function do? It gets rid of what the actual function did. What is the inverse of an exponential? Base e exponential. ln. What is the inverse of ln? Log base e. What is the inverse of ln? Ln gets rid of an exponential. What would get rid of an ln? An exponential. What would get rid of a square? If you square a number, what will get rid of the operation? The square root. If you took the square root of x, what would get rid of the square root? Square root. So, in this case, what is going to get rid of sine? So, let's see. Suppose I have sine pi over 6, which is equal to 1/2. That we know from the unit circle. I want to apply the inverse function on both sides. So sine inverse of sine pi over 6. If I apply the inverse on one side, I should apply the inverse on the other side also. So sine inverse of 1/2. What would happen to inverse the sine? It comes like squiggly line. So pi over 6 must equal to sine inverse 1/2. Take up your calculator and tell me what the value of sine inverse of 1/2 is. If on a TI-84, it's simply do a second and then hit sine, it should give you sine inverse. So if you plug in sine inverse of 1/2, you would get 0.52. Okay. So pi over 6 is sine inverse of 1/2. In a similar manner, let's say I did sine inverse of 1/2, and we just know that it's pi over 6. What is going to get rid of sine inverse? Sine. So take sine on both sides, sine of sine inverse of pi 1/2. Good. What would happen to the sine and sine inverse? Quickly. So 1/2 is sine of. But the inverse sine function is called the arcsine. Now you might wonder, well, why do we call it arcsine? Well, when you plugged in a value of t in the inverse function, right there, what did I get? I plugged in 1/2 and it gave me pi over 6. Yes. Now, what is pi over 6? Pi over 6 is the angle corresponding to an arc length of 1/2. Yes. In a unit circle, if you are at 30 degrees, sine is over here, the coordinate, y coordinate, that is 1/2. So it gives you the angle swept by the arc, which is why we call it arc sine. It is going to give you the angle. In simple terms, sine inverse t. That said, how is the domain and range? How is the domain and range of a function related to its inverse? Let's simply look at the interval 0 to 2 pi. The reason why I'm simply looking at 0 to 2 pi is because if we know the basic or simple unit cycle, we can extend the idea to others. So, what is the domain of sine t? True, but if I simply look at 0 to 2 pi, it's easy. 0 to 2 pi. If we plug in values, any value, 0 to 2 pi, what are the values of sine? Start at 0, go around back up to 5. What are the possible values for sine? In other words, what is the range of sine on the interval 0 to 2 pi? Large enough.
-1 to 1.
-1 to 1. Do we agree? Now tell me, what is the relationship between the domain and range of a function and its inverse? I'll give you a hint. The original function takes the value of x and puts it on the y-axis. The inverse function will take the value of y and bring it back to the x-axis. So the axis. They switch, in other words, range becomes the domain becomes the range. So good. What is going to get rid of the cosine operation? Cosine or cosine inverse of 2. What is the domain? We'll simply look up 0 to 2 pi, cosine 0 to 2 pi, one full revolution. Over that interval, what are the values of cosine? One full revolution. What are the possible values for cosine? I'm going to sprain my hand doing it constantly. So hurry up. What is it? -1 to 1. Range becomes domain becomes range. -1 to 1 and 0 to 2 pi. That leaves us with one other thing, which is tangent. The inverse of a tangent function is tangent inverse. What is the domain of a tangent function? You can plug in all values. Take, yes, 0 to 2, except tangent is sine over cosine. So any place where cosine becomes 0, tangent will cause a problem. So for what values will cosine become 0? Pi over 2 and 3 pi over 2. So we can look at the domain of cotangent. So the other side, because 1 over tangent is cotangent. So 0, can I include 0? Sine over cosine. Cosine 0 is 1. So what's the problem? 0 to pi over 2. Can't include pi over 2. I can include 2 pi because sine 2 pi is 0, cosine 2 pi is 1, 0 divided by 1 is not a problem, so like speaking. And what about the range? The range of a tangent function, mind you, a tangent function has vertical asymptotes. That is my hint. That said, what is the range of a tangent function? So since we have a vertical asymptote, which simply means negative infinity. positive infinity. Cotangent had a range of negative infinity to positive infinity. So tangent will also have the same. Range becomes domain, domain becomes range. So negative infinity to infinity, over here, 0, pi over 2, pi over 2, 3 pi over 2, 3 pi over 2. Good. You can try this at home. What would get rid of a cosine operation? If you have cosine of t, what is its inverse? Excuse me, I didn't want to say cosine, cosecant. Let's. Inverse of cosecant. Cosecant or cosecant inverse, secant inverse, cotangent inverse. So cosecant inverse, secant inverse, cotangent inverse are simply inverse functions of cosecant t, secant t, and cotangent t. Does that make sense? Don't write cosecant t as the inverse of sine t. One over sine t is not equal to sine inverse of t. Good? In a similar manner, cosecant inverse of t is not equal to 1 over cosecant of t. Good? Now, the calculator has sine inverse of t, cosine inverse of t, tangent inverse of t, using which we can find cosecant inverse, secant inverse, and cotangent inverse. Good. So suppose you want to find cosecant inverse of some t equal to, well, it's an angle, so it has to be in the range 0 to 2 pi. Let's just take pi over 7. And I want to find the value of t that would give me pi over 7 in a cosecant inverse function. How would you find that? Take the cosecant on both sides. The cosecant inverse of t would be cosecant pi over 7. Quickly, and t. Or do I have cosecant on my calculator? No. What should I do? Abort mission. Huh? Not the inverse. Very reciprocal of what function? Sine, cosine, cosine.
Right? Or no, well, you use sine in it, right? Isn't it the 1 over
So this would equal to 1 divided by
sine?
sine pi over 7. Do we have sine in our calculator? Okay, what do we get? And if you put cosecant to 0.30, you would get pi over 7. Excuse me, cosecant inverse of 2.30, you would get pi over 7. So that's how you find the value of t. So if you want to get rid of a cosecant, you take cosecant inverse. If you want to get rid of the cosecant inverse, you take cosecant on both sides. Are we clear? Yes, okay.